All right. So I'll comment this, basically, that this is joins. The first join I'm going to show you is a cross join. And I'm also going to put in this comments because I almost always get assignments where people come and they do a lot of cross joins. The thing about cross joins is you don't want to do them most of the time. They're a very rare join. So I'm going to just write a quick definition. However I want to do that. A cross join basically joins every record from one table with every single record in the next table. What it does, it's sometimes called a Cartesian dump. So you have one row, so you have one customer here, and then you would have, oh, I don't know, sales or something. If you do a cross join, that one customer would be joined to every single sale in the sale table. And then the next customer would be joined to every single sale in the sale table. You get an exponentially larger result. Come on in and get set up. So cross joins are fairly rare. They're not illegal because there are some situations where you might actually want to do that. If you want to look at, like, say you had employees and schedule times and you wanted to look at every possible permutation of a schedule, a cross join can give you that. It'll give you every employee with every possible work time. There are certain kinds of matrix mathematics where you want to do that, where you want every record matched with every other. You want to see every single possible match. But it's rare, and you generally don't want to do this, right? But I'll show you real quickly. Joins are also, they're about, and the other thing I'm going to say, rare, sometimes happen by accident. How do you know it happened? Typically, if you do it by accident, you're expecting 10 records and you get 100. That's a good sign. Also, a cross join, if you're not careful, can kill your computer. So you got 1,000,000 records and you accidentally did a cross join with another table with 1,000,000 records. You've now got 1,000,000,000 records in memory, and it just freezes up the usual computer because they don't have that much RAM. So I'm going to show you, let's do just a couple of, so I need to use Community Assist, actually. And I'm going to we'll look at two tables. So I'm going to do it from grant type. So we'll look at every possible grant type. So there's 13 different grant types. And then let's look at, so if we did a selection with person and grant type, right? So there's 130 persons, and so it'd be 130, 13 for each of those. So what would that be? Is it just times 13? So I'm going to do it the right way first. I'm going to do select, and we'll just do select person last name. And then I'm going to do comma and do grant type name. And then I'm going to do from person. And I'm going to do cross join grant type. Okay. So when I run that, Notice I have 1,677 rows. I don't know if you can see that. And so each of these persons, actually, let's order by, so you can see that how it works with the people. I'm going to order by person last name. It'll be clear what's going on. See how Alan is matched with every single grant type? And then Anderson is matched with every single grant type, and then Baker is matched with every single grant type. That's what a cross join does. 99% of the time, you do not want to do a cross join. But I do want you to know how to do it in case you ever have to, and also so you can recognize them if you do them by accident. With this terminology, with this syntax, you can't do it by accident, right? It's very explicit if you're doing a cross join. But let me show you, there's an older syntax that you can encounter still where these things can happen by accident. One of the ways that you used to join, when you do a join, this would be, you would want a normal type of join, but you accidentally get a cross join. If I'm going to do like select person, last name, grant type, name, and I'm actually going to do like grant application date. So this has 3 tables in it, right? In an older join, although maybe I should do this just as a straight. Let's do it straight, and then I'll mess with it to show you how they happen by accident. So doing those, I'm going to do from person, comma, grant type. And if I run that, this actually has exactly the same result. Right? So that's also a cross join. It's an older syntax. The thing about it is it's not as explicit at what's going on. And this could happen by accident, because this could be happening because you forgot to make a connection. Right? When you do this syntax, you have to make a connection. So I'm going to do one more version of this, the one I was going to do a second ago. Let's say you're not looking for it. You just want to see the grants and what types they are. So I'm going to do grant. Actually, it's application. What is it? Application. What is my field name? Grant request. I think I changed that in the newest version of that. All right. So grant request date. And we'll do grant request amount just to make it. So I'm going to show you an accidental cross join. So the way you do this, if you're using the old syntax, is you would do where, and I'm going to say where person.person key equals grant request dot person key. And I need to do grant request here too. So we've tied everything. We've tied 2 of the tables together, but we've actually left out the 3rd one. This one is basically, there's going to be an accidental cross join here between grant and grant request. So when I run this, there's 1,157 rows. There's only like 50 requests. So you know that something's wrong. And what's wrong is that you would have to also tell how the other two tables relate. So I'd have to say, and grant type dot grant type key key equals grant request dot grant type key. So we're getting a little ahead of ourselves, but this is how you would do it where it's not. This time I only get 89 rows, which I think is about right. There must be about 89. So if you leave this off, I'm going to comment that out. Then you have an accidental. I just want to say, be careful of cross joins. In your assignment, you have exactly one cross join, very first one. None of the rest are cross joins. And I say that because every quarter I seem to get people that do cross joins all the way down. And they are not what you want. Does that make sense for a cross join? I would always use this syntax, because then you know what you're doing. This is slightly more efficient in terms of typing, but this is a lot clearer in terms of what's going on. We're going to talk about the same with the inner join. When I do the where and the and, this is an old syntax for an inner join, the normal kind of join. But it has the problem in that it doesn't throw you any errors if you accidentally leave out a join, relationship there, and you can get sneaky sneaky kinds of cross joins in there. Up until like version 6 of Oracle, this was the only way to do a join in Oracle. But every modern version of every database supports join syntax now. So I'm going to show you the normal join syntax. So cross join is part of that. And then I'm going to do an inner join. We kind of already did, but let's just do one. If you do like select star from employee, so I'm just going to run that. You'll see, you don't know what their names are or anything about them, so you might want to know that, right? So we'll just do a simple join to get those things. The idea of a relational database, you break things up into smaller and smaller sets. But when you want to look at the data, typically you want to pull it back together. Humans want to see things in context. Knowing that this employee is 5 tells you nothing. So we'll join this. I'm going to do select person last name, person first name. I'm going to add notice those are from person. And then I'm going to add employee hire date and employee annual salary. I think salary is something I took out of the new version too. All right, so one of the things when you're doing a join is you just list all the columns you want to see in the order you want to see it. You don't worry about what table they're from, right? So these two are from one table and these two are from another table. Doesn't matter what table they're from, you just list them out. Then you do from one of the tables. So I'm going to do from person. Okay. Then you do inner join with the next table, which is employee. And you have to say how they relate. And to do that, you use an on clause, and you say like person dot person key. Right, this is the primary key of person. equals employee.person key, which is the foreign key in employee. You're telling how the table relates, primary key to foreign key. They actually don't have to be keys, but that's generally how it works. One of the things is that both of these need to be the same. They don't have to be the same word. If you named your foreign key something different, that's okay. But they do have to have that relationship. This will work with any integer over here, right? But your results will be meaningless. For your results to be meaningful, you need to have basically match like to like. Primary key to foreign key is probably how you should want to think about it. The word inner is optional. Joins, if you just use the word join, it assumes inner. Inner join, what inner joins do is that they return all the matching records. So all the matching records. This is 90% of the time, this is what you want to do. So when I do this, there's 130 people, right? But I'm only going to get the 6 that match the employee person key. It only returns the matching records, right? So there are 6 out of the people table that match, person key in the employee. Questions on that? Yeah.
Yeah, just make sure I understand. So we're telling them to match on the person key, but you don't have to. I guess I thought you would tell it to like match to the employee key, but is that a different?
That's a different thing, and if you do that, you're going to get
all the or like a cross join.
Well, it won't be like a cross join. What you'll get is weird, and it will look okay. But notice who our people are. These are the correct people: Mary Lewis, Tina Moon, Allison McGraw, Tracy Lee, etc. So I'm going to match it to the employee key. It won't throw an error. But the employee key is not what relates it to people, right? The employee key is just the primary key of employee. The thing is that there are, so the employee key is like 1 through 6. You know what I'm going to do? I'm going to do person.person key. I have to do this, the person.person key, because it's in more than one place. And I'm also going to put employee key. I don't know if I have to do. All right. When I run that, see we get the first. That isn't quite right though. The person key. I don't think the first 6 are the employees. But notice that these are different people, right? So actually, so let me do.
Well, when you did it the first way, like what data is it looking at to match these people? So there's not like what's the common
Person key.
Also the person key.
So if you let's look at employee again, just straight. See, there's a person key here that relates to the person table. This says that this employee is number 5, has that key in the person table. So let's do real quick. I'll just do a select star from person. Where person key equals 5. And it should be Mary Lewis. Her key, her primary key of that row is 5.
Oh.
And that's what relates it to the employee. So when I do an employee, the only thing I have of that, because I don't need to repeat any of that stuff, all I need to do is make a connection, and the connection is here. That's how relational databases work, basically. You just relate you repeat a primary key in another table as a foreign key, and this is the foreign key. Again, if I do employee key, I get the first 6 employees because it's just matching 1, 2, 3, 4, 5, 6. So they're not the employees, they're just the first 6 people in the person group. The dangerous thing about that is that if you aren't careful, you might just assume that's right and go ahead, right?
So, sorry, one more question.
Sure.
Under on the side where it lists like out the columns, I guess why I asked that is because I didn't see employee keys, and then I see there's another little section that says keys, and then it says person key. So is that what's changing it?
So you mean over here?
Yeah, on the left.
Yeah, let me
I
zoom.
didn't see person key under the employee table, which is why I was confused.
Right.
Then I saw there's another thing that's right below it says keys. So that's what it's matching?
Right, so if you look, so let's look at employee. So, and if we look at columns, it also has keys, but notice the employee key is a primary key and person key is foreign key. Also, if you look at the database diagrams, if you look, it takes a while for me to load, but there's an employee, you can see the relationship between person and employee somewhere in here. So there's person and an employee. So the key points to the primary side, which is person key, and then person key is repeated down here. It's the relationship.
Okay. That makes sense.
And as I said, the other thing that you can do here, now I put the employee key, so if I run this one again, yeah, so this one's correct. The employee key is 1, but the person key is 5, right, 2, 12. And when you match the employee key, it just gives you the 6. So if I do this one again, it gives me the person key and the employee key and then the proper names again. I added the keys just to be clear. Typically, you can ignore the keys when you're doing these queries. I mean, in terms of presenting, it's what you use to connect things, but you don't have to show them necessarily.
It won't mean anything.
Because they don't mean a lot, yeah, other than that connectivity. I'm going to do some slight variations of this one, just to show you that you can. So I'm just going to copy that. We're going to expand it a little bit too. All right, so I told you can do without inner. Inner is optional because joins are assumed to be inner joins. You can also alias your tables if you want, but then I have to do a P here. When you use an alias, you have to use the alias. Okay. This can save you a lot of typing. However, I suggest you don't do it if it confuses you. So P now stands for person, E stands for employee. And this is, so I have to use the P here, even though I declared it down here. One of the things that tells you about SQL, it doesn't process in the order that you write it. Right? When you do a C# or a Python query, you know that it's going to operate row by row, line by line as it goes down. That's not the case here. It actually does the from first, looks at the criteria if there is any next, and then at the very last thing is it selects the columns underneath, right? You don't have to worry about that, except that it has this odd effect that even though I alias this down here, I have to use the alias up here. The other thing I want to mention is that, anybody know why I have to do P dot person key or person dot person key there?
Because it exists in the other table.
Right, because it's in 2 tables. So it needs to know the context. Which table are you pulling it from? With an inner join, it doesn't matter. With a outer join, it does matter which table you take it from sometimes. But So I just did P, person key. So you basically have to qualify it. They call this qualifying it. Full qualification, if you ever have to do that, is server name, because you can query across servers. So first, total qualification would be like server name dot database name dot schema name, which we'll talk about more later, dot column. Actually, dot table name dot column. All right, no, just table name, just dot table name. So you can do a dot notation that gives basically a path of where to get it. You can query across databases, and you can query across servers. So say you had a human resources database where all of your real employee information was, and you just had a minimal amount here, but you needed to get that for an employee in this database, you could query across databases to pull that in. We will, a little later, we will do a couple things that are cross database. Don't think we'll do anything cross server, but you can.
We can write the from statement, like
Yeah.
the first part if we want to.
So, no, you can't.
Oh, okay.
SQL has to be in this order, but it isn't processed in this order underneath. The dirty secret of SQL basically, you just say what you want to do, not how you want to do it. Underneath, it's being parsed by C++ into data structures and looped through into all sorts of neat things, but we don't have to worry about that because it happens underneath in the data engine. But as I said, it occasionally, there's little artifacts in that it doesn't process things in the order you write them necessarily. But you do have to write them in this order. So this will give us exactly the same results. Right? It gives you, so this is basically with aliases for table aliases. And leaving out inner. So inner join is always optional. I use it though, because it just makes it real clear what kind of join it is. So I usually do say inner join, even though it works just fine without it. All right. So let's say we wanted to know what position an employee has. So if we look at employee here, I want to do like not a, I want to do 150 rather than 200% zoom. Okay. So I'm going to do a plus here. When you look at employee, there's a position table here, right? This gives the names of the positions. This is the employee one. And this is actually a linking table between employee and position because a couple of employees have more than one position. So in order to get the position name for any employee, you have to go through this table. So we're going to have to join employee to employee position and employee position to position. Later, I will show you how to do views, not today. That will show you, so you can write one of these, especially when they get really complicated, and you can write it just once and save it. So I'm going to add, we don't really need employee key and person key, so I'm going to take those out. But I am going to add position key. Oops, actually, let me not do that here. Okay, let's go down to here, copy it and do it there, because I don't want to remove the example. And I also want to get rid of my zoom. All right, so we've got this. I'm going to get rid of these person keys. We just don't need them. We will need them for the matches. Do you want this alias, or do you want me to spell out, just have this table spelled out? You want the alias? All right. Just let me know if it confuses at any point. So I'm going to leave the person with the person key. I'm going to add, where do we want to do it? Let's do position name. Okay. And it's red underlined because we haven't got there yet, right? We don't have a table that has a position name column in it. So as I said, we have to go from employee to employee position. So I'm going to do another inner join, and it will be with employee position. And I'm going to do, I'll make it EP. And then I have to say how it relates, just like I did before. So I'm going to say EP dot, we'll do employee key equals E dot employee key. So again, we're showing how those two tables relate. The employee table is related to the employee position table by means of the employee key. And then we're going to do an inner join with position. And I'll just make that P. Oh, I can't make it P, can I? And I'm going to say on POS dot position key equals EP dot position key. So I'm showing how all the tables relate. So person, last name, person, first name are from person. Position name is from position. These are from employee. There's nothing there from employee position, but we have to go through it to get to position. So we're doing it from person, right? We have to get that. And we're going to join it with employee. They are joined by the person key. We're going to join employee to employee position by employee key. That's what joins them, right? The employee key is the primary key in employer, and it's the foreign key in employee position. And then we have to get to the position name, we have to go all the way to position, which is joined to employee position by means of the position key. Sounds complicated. It can get worse. Notice how you just keep adding inner joins. This one has join up there, and all of these could be joined as well. But you can just keep adding them as long as you need to. Some real-life databases have literally hundreds of tables. So, I mean, it would not be unreasonable to see one of these with 10 or 15 joins. One thing on performance, the more you have to join, the slower it's going to be. So there are times when you're running a database that needs to perform that you pre-join things and create a new table based on the joins, just because it runs faster. It has the danger that it may not be up to date all the time. So I'm going to run this. And basically we get, notice Mary Lewis has two jobs. She's a web donation supervisor and a manager. I don't think anyone else has two jobs. But does that make sense? It's not hard. The syntax of this isn't hard, but you do have to figure out how to trace what tables relate to what and what the primary key, foreign key relations are. You have to, basically with these inner joins, you have to kind of know what the structure is of the database. That diagram can help. And you can also, I mean, it tells you over here what's primary keys and what's foreign keys, etc. Okay, so our inner joins make sense? So I think I'm going to do something now that'll make less sense. It'll take a little more explaining. Maybe we'll try an outer join. So an outer join returns, typically it returns everything from one table, whether it's matched or not. I can't type. What this is really good for is finding unmatched data. So inner joins only return related data that has matches. With this, you can take one of your tables and you can return everything in that table, whether it has a match or not. So I'm going to do an example. We have grant types, right? So I'm going to list that again. I'm going to just do select star from grant type. So we have a bunch of grant types. So we have 13 of them. The question might be, and let's look at grant request too. I'm going to do select grant request. Star from grant request. So when I run this one, notice that there's a grant type key, right? It's a foreign key. So it's what they're asking for, what kind of grant that they're asking for. So you might have a question like, what grants have never been requested? You know, what in all of these, so we have 13 grant types. Are there any grant types that have never had a request for a grant? And that's what an outer join is good for, that kind of question. So what I am going to do, I am going to select, let's do grant type name. And then I will do, just on the other side, I'm going to do, we could either do it here, let's do, I'm going to do grant request key though, because that one's real obvious. So that's from grant request. All right, so I'm going to say from grant type, and if you want to alias it, we could do it as GT. And I'm going to say left outer join can't type, left outer join grant request on same thing. I have to say grant type. So it's actually, this is GT. Let's make this GR. So on GT dot grant type key equals GR dot grant type key. That's how the tables relate. Before I run this, I'm going to do outer join. Anybody have an idea what left means in this case? Just curious.
You think another, not SQL, like would look at the leftmost part of the data that you.
Well, left is simply the first table that you list is the left.
What's left over? Oh,
No, it's literally just the left table, in the sense of right and left.
Oh.
And the second table is considered the right-hand table. So if you were Hebrew, you might be more comfortable making a right-hand join here, which is they go through. The word outer is optional, left is not. Because you could do this as a right table. The table that you list, right now, we're saying this left table, we're gonna return everything from grant type, but only the matching records from grant request. Does that make sense?
So the period then on that line there is the left side or the right side of the period?
Well, it's not the left side or right side, it's which table.
Is that coming from the primary?
Well, no, just the first table is your left table, the second table is your right table. So it's sort of like if you were to put the two tables side by side, this is your left one, this is your right one.
So if you say right outer join, it's going to return the.
It's going to return all the grant requests, but only the matching grant types, which actually won't show us anything. But if we were to do that, and I will do it as a right hand too, we just have to flip which table we did the from first. So I'm going to do this, and then I'm going to make a little modification of it, because I want to show you what it does. So I do, oh, I hit the wrong thing. Never mind that. I'm going to execute. I should just do F5, it's faster. So we're looking at all these grants, but at the very bottom, notice there's a couple of nulls, right? Because they don't have any matching key in grant request. So holiday and funerary have never been asked for. And rather than looking through everything to see just where these matches, and there's no null in grant request, right? There's only a null in the results set, not in the actual table. So if I wanted to see just the ones that had not been requested, I could just do where grant request key is null. So if I do that, it just limits it to the two that have never been requested. It's really good for this. Things that you would want to, like if you were found this and nobody had ever requested them, you might consider getting rid of them as options, right? Or what's really useful too is if you have a customer that never made an order, right? That probably happens on the web pages a lot. Somebody registers, starts an order, and then cancels it, but their name is there. So if you might have customers that never made an order, you might want to clean those out once in a while. You might have products that nobody has ever ordered, you know, that you might want to consider, do we really need this product if nobody has ever ordered it? I mean, that's what outer joins are really good for. You know, they return everything from one table, whether it's matched or not. But this is a place where it's really important that this one be in the table that you're returning only matches from. Otherwise, there won't be any nulls that show up. The grant type name is from the one where we're returning everything. The grant request one is from where we're returning only the matching records. So I'm going to reverse this and do it as a right. Outer join. The result will be the same, but I have to change it slightly. So I'll copy this, but I need to make a couple of changes. I don't do right outer joins just because I don't think that way, I guess. Again, if I was Hebrew, maybe I would, because they write right to left rather than left to right. So I'll do GR there. And then this one will be grant type and GT. And then I have to change this to right. And it has exactly the same result, but I had to flip the tables. Your leftmost table is your first table always, your right table is the second table you left. Two couple of other little things, and then we'll probably be done demoing about 11, so we should have some time to work on these. Is this making sense? Okay. So there is one other, there's actually other kinds of joints, but most of them are pretty rare and kind of funky. But I'll show one other one, which is a full join. And you can get some of the same effects from a full join. So I'm going to do basically this, and copying this again for speed. But I'm going to change it to a full join. So instead of, and it doesn't matter which table is which in this case, I'm just going to say full join. And what happens when you do this is it returns everything from both tables, whether or not they match. Right, so it's literally, it's going to bring back everything from both tables. And again, if we go down here for a ways, we will find the same nulls, right? The full join in this case does exactly the same as a left join or right join. It doesn't always do the same. Like if there were some, this would be really bad relational design. But if you had some foreign keys over here that don't exist in the primary table, it would give a null over here, right? But as I said, that would be a sign of really bad database design. Which I suppose it would be useful for that to say, wow, how did we get foreign keys that don't have a primary key? It'd be like having a order without a customer, right? Or sold a product that doesn't show up in inventory. You know, just bad database design. But it could be useful for finding those things if you have bad database design. But a full design, most of the time, a full join does pretty much the same thing as a left join. Okay, I want to do one other thing with an inner join, and then we'll call this good. I just want to do a complicated inner join where we do some aggregate stuff. You guys remember what aggregate stuff is? Like average and... So let's do, I'm going to do select grant type name. And then I'm going to do some grant request amount. I think that's the name of the field. I'm also going to do like average grant request amount. And maybe just since we're putting tons of aggregates in here, let's do a count. I'm going to put it up front there. Count. Okay, and I'm breaking this up just to have it on screen better. And I should alias count. So I'm actually just going to alias it as count. This one I called total. I don't have to put it in square brackets because it's not. And this one I will call average, which I can do because average isn't the name of the function, it's AVG.
Misspelled the grant type name.
Oh,
Left out a T.
I left out a T. Thank you. Okay, so then I'm going to do, so this is from two tables, right? So I'm going to say from grant request and I guess I'll alias it. And I'll do a join with grant type. On grant, actually GT. Doesn't matter which comes first here, actually. So I do grant type key. Even though it's primary key, foreign key, it actually doesn't care what order they are on around the equal sign. So, but if it's easier for you, you might think of primary key, foreign key. Right now I have a foreign key, primary key. And then because this is they're aggregate functions, what do I have to do? Anybody remember? What is grant type name? What about it? It's not part of any aggregate function, right? So I have to group by it. So we're joining tables, but let's look at, and we're doing aggregates. And I just want to show you, this is really useful. So it gives us each of the grant types, right? It gives us how many of each there were, how many requests there were for each. It gives us the total amount of the requests, and it gives us the average amount of the requests. And if you wanted to, I'll go one more. I'll copy this. I'll add the format stuff if you want to format it. But I'll do it as a copy of this. And as I said, I just wanted to show you with the joins and stuff, you can start getting fairly sophisticated reports, and they can even be more so than this. So I'm going to do format, and then I'll just do, actually this is a number. This one shouldn't be formatted. I mean, it's just an integer. So I'll just do the $sign. Oops, not 3. £, 1, 2, and we'll always guarantee that they have at least 0, 0. Close the quote. And I'll just copy that. So I'll do the same thing here. Boy, my mouse is just floating. It's not moving very well. Comma, paste. Okay, so the only difference between this and the last one is that this one will have $signs and be a little prettier.
So what would happen if instead of pound 0.00, I did pound 0.00.00? Would it force a number?
No, actually the pound doesn't force a number. The 0 forces a number.
Yeah, so if I change the 2 pounds, so I think 1,000 could be left alone, but
You could do that. I mean, that means that if you had something that was less than 1,000, it would put a 0 in front of it. So I figure there's always a, I mean, this one, the reason I do this, but yeah, if you put a zeros here, then it would always, if you had like a $20 sum, it would be 0.20. It would force a digit there. But so that's, I just wanted to show you could do these kinds of things, which are very useful. Starting to get a decent report out of it. When you brought it in, if you brought it into formatting, I mean into the brain is gone. If you brought it into a reporting software, you can realign these and things. But a lot of times in the past, this was your report. You know. So I think that's it. Do you guys have questions on joins? Just to reiterate real quickly, because we basically covered 3 kinds of joins. There are some things that are, all of these are equijoins. If you ever see that term, that means they use the equal sign in the relations. It is possible to use a greater than or less than sign in a join, but the reasons for doing that are usually obscure and strange. So these are the common joins. Cross joins are not real common, but they can happen by accident, and sometimes they are useful. Like if you're looking at scheduling and you want to look at every possible combination, cross join could give you that. The thing is, don't use cross joins unless you really have a reason to. Inner joins are the most common joins. It's just showing records that match each other, right? So those are real common. You can have as many inner joins in there. We have 3 there. You could have 5, 10, 15, however many it takes. You have to include all of the intermediate tables, even if you're not pulling records from them. I mean, pulling columns from them. And then we did outer joins and full joins, and then I just showed you that you can do aggregate functions and joins and get good results too. Well, this is the join assignment, but from now on we'll be joining tables. So almost every query will involve some kind of joining. So you'll get lots of joining exercise beyond this. I'm going to, I'll stop the video, I'll paste this right away, and we've got about an hour if you can work, or you can take an early lunch, I don't care, but I probably will start something new next week. So, video first, I guess.